Hello. So this is just a very particular type of story problem that uses systems of linear equations. And it's like, we'll see, I think, three examples, and this is going to cover two chapters. But what you'll kind of realize, at least I hope, is that they're actually all exactly the same. So whether we're talking about like one thing or another, it all kind of turns into the exact, mostly the same type of problem. If you've ever heard of like a mixture problem, that's what we're getting towards. So here's kind of like more just like a number theory one. So it's a lot of words. The sum of two numbers is 90. If 20 is added to 3 times the smaller number, dot cameo, the result exceeds twice the larger number by 50. Find the numbers. So, okay, a lot of words. But you can tell what we're trying to do. We have two mystery numbers. We know two things about them. One of those things is pretty simple, that they add up to 90. The other thing we have to do a little bit of translating to figure out. So, but that's two equations, right? Two equations, two unknowns. We can solve that with substitution or elimination. That's all we've been doing this whole time. Okay, so we have, we'll call them x and y, whatever you want. X plus y is 90. And then, okay, if 20 is added to 3 times the smaller number. So at this point, it doesn't matter which number is smaller, because we don't know. So let's say it's x. So if 20 is added to 3 times a smaller number, it means 3x plus 20. And the result exceeds, which means more than, it exceeds twice the larger number by 50, which means it's 50 more than twice the larger number, which means it's 2y plus 50. Okay, so what did I just say? 3x plus 20 equals 2y plus 50. Okay, I guess I call them A and B. So that's the obvious one. And generally you'll see that. One of the equations is kind of obvious, and the other one is maybe a little more in depth. And there's that. Okay, so from here, I mean, I'm kind of going to cruise through the solutions because really the work here is setting it up. So now it's just a system of two equations, two variables. We have a bunch of different ways, well, two different ways we can solve these. And the other thing you'll find for these is they're pretty conducive to using substitution, because if you look at that first equation, it's just a plus b equals 90. Substitution relies on solving one of the equations for one of the variables. So just in your head, you can say, oh, well, a is 90 minus b, or b is 90 minus a, right? That was pretty easy to do. You can use elimination if you want, line them up, but I think I'm just going to use substitution probably for all of these. Okay, and again, this is the part we've kind of been doing, so you should be good at this. It's not terribly hard. So do a is 90 minus b, stick that into equation 2. I didn't label them, but you know, the other one. So it's going to be 3 times 90 minus b plus 20 equals 50 plus 2b. And the rest is just algebra 1. Distribute, combine like terms. I think in one move, I'll probably add this 3b over here, and I'll subtract this 50 over here. Yep, that's what I did. 5b equals 240, divide by 5. B is 48. And then just the last thing with these is don't forget to answer the whole question. It said find the numbers. But that's not the hard part, because it's always, you can always jump right to here and just say, okay, if B is 48 and they add up to 90, 90 minus 48 is 42. That's the other one. Like that. Okay, so and then it would be pretty easy to check. Okay, is 3 times 42 plus 20 equal to 2 times 48 plus 50? Yeah, it is. All right, so here's what we mean on a mixture problem. This is the last one was just numbers. This one has some, some concepts. I think it has. Oh, it has money. Okay. So we got $8,000 to invest in two separate accounts. There's a stock fund and a bond fund. Now, one of them pays 4.5% annual interest, and the other one pays 6% annual interest. So before you ask me why wouldn't we just put the whole 8,000 in the one that pays higher interest, the answer is you probably would. But in this problem, assume that the higher interest one has more risk or something. So that's why we're divvying it up between the two. We're diversifying. That's the word. Yeah, well, we earned $405 in interest at the end of 1 year. So we want to go back in time and figure out how much was invested in each account. Okay, so the one thing I'll make clear is just how simple interest works. And it really is simple interest. So let's say I invested the whole thing in the bond fund. How much money would I get? I would get 6% of $8,000. Okay, so that's literally all you do. At the end of 1 year, there's no compound time period or whatever involved. Okay, so if you invest P, remember we use P for the principal, dollars at rate R, you literally just do the investment times the rate. Okay, so you can see, so we're going to call one amount X and one amount Y. And for the next 3 problems, we're going to make a table like this. So take a second and copy this table down. Now for this problem, do you have to make a table? No, you might be able to get away with just working it out. But do it anyways, because for the next couple types of problems, they're a little harder to set up. So you're going to want to make this table. And then again, notice that it's all kind of the same thing. So you take your fund. So you take, this is how much you put into the stock fund. This is how much you put into the bond fund. Really this is. And then these are going to, the third row is going to be your totals. And then we're going to make one column for principal, so how much we put in, one column for rate, which was given, and one column for the amount of interest we're going to make. Okay, and that's going to give us our 2 equations. So it's all about what do we know and what don't we know. So the principal, how much we put into each, we don't know. That's literally what the problem is asking. So we can call this S and this B, or this X and this Y, or whatever. The total we put into both accounts, so it's kind of like you're multiplying across and adding down. The total that we put into everything is 8 large, right? So that we do know, so that'll go there. Okay, I called the first amount X, the second amount Y, and again, that's our first equation. That's the simple one. Our first equation is just X plus Y equals 8,000. That's what we know, is that the total amount we invested was 8,000. Okay, so the rates, and this is where it's a little weird. So we know the rate, the interest rate we're making off the stock, it's 4.5%. We know off the bond, it's 6%. For the total and the rate column, we actually don't really put anything because it doesn't really have any meaning. So just because you made a table doesn't mean you have to fill in every cell in your table. So you could add those 2 rates, but it doesn't. That's not really how it works. So anyways, put in the 2 rates, and then remember, you're never putting, like the number is 4.5%, you're not using that number, right? What number are you using? Well, I can't hear you. So I assume you just said, oh, I'm using 0.045. And then for 6%, I'm using 0.06. Because you know how percents work. All right, so interest, this being simple interest, whatever the amount X is, the amount you made off of that portion of your investment is just 4.5% of X, or 0.045 times X. So that's why the table is nice, because we're multiplying this way. So this is going to be 0.045X. This is going to be 0.06Y. And then this is going to be, so again, you're not, well, you are adding them, but you actually know the total interest you made. You don't know how much you made off of each one, but you know the total. It was given. It's 405. So that's going to go here. All right, and then your 2 equations come right out of the table. X plus Y is 8,000, and 0.045X plus 0.06Y equals 405. If that makes perfect sense to you, then maybe you can not make a table on a money problem like this. Just say, okay, 45% of X plus 6% of Y equals 405, because that's your second equation. There they are. Okay, once again, we want to use the simpler equation to solve the more complex equation. So substitution is great. So with the first equation, you can just say, okay, X is 8,000 minus Y, right? Or Y is 8,000 minus X. Doesn't matter which one you use. And then that's going to go into the equation with the decimals, and then we're going to do, you probably use a calculator at some point. So here's the work. X is 8,000 minus Y. That goes into the second equation. So it's 0.045 times 8,000 minus Y plus 0.06Y equals 405. Like that. You see what I mean? Now it's the same as the last problem. You can forget about stocks and bonds and just do the algebra. Apparently 0.045 times 8,000 is 360. And then just you're combining like terms. So I did two things at once. I did 0.06 minus 0.045, and I did 405 minus 360. And then you just divide by 0.015, and you get y is 3,000. Okay, and then the very last step is the easiest step. If y is 3,000, what does x have to be? You don't need a calculator. It has to be 5,000. Like that. So at the end of the day, I always like to see some units, and sometimes I like to see like a complete sentence for your answer. That just forces you to remember which one was x and which one was y. So you invested 3,000 in, nope, I'm not backwards. Y is bonds. So you did 3,000 in bonds and 5,000 in stocks for whatever reason. Okay, so this is more of a true like mixture problem because you're literally mixing two things, but it's not as obvious, at least I don't think, how to set this up. So let's do it. A food co-op sells almonds for $7 a pound and peanuts for $3 a pound. You apparently work at the food co-op and you want to make a 20-pound mixture of the two, of almonds and peanuts. Very nutritious, lots of protein. Okay, that sells for $4 a pound. How much of each should you use? So you see what I mean? It doesn't really jump out, to me at least, how to set at least the second equation up. You know you want to make a 20-pound mixture. So if you call almonds A and peanuts P or whatever, then you know A in your mix, A plus P has to be 20. Okay, so that one kind of jumps out, but the second one doesn't. So here we go at the table. So same thing, you can call it mix or you can call it a total. Your mix is going to consist of a bunch of peanuts and a bunch of almonds. You just don't know how many weight-wise. So here are your columns. All right, so now it's the price per pound that's kind of the rate. It's always like per something. So so the amount you use, which once again, exactly the same, you don't know. It's just X and Y, but you do know how much your mix is. Your mix has to be 20 pounds, so that's known. And then it's the price per pound, and then once again, the third column is the product of the other two. So if we have, 5 pounds of peanuts at $3 a pound, that's going to be 15 bucks. How do I do that? 5 times 3. So these are going to be products. Okay, so I used capital A and capital P, which we don't know, but we do know that A plus P is 20. Price per pound, we know once again, this is a little different. And all the real mixture type problems are going to have this. The price per pound of the mix is something we know. It's $4 a pound, right? And it makes sense that it's somewhere in between these two things. So that we do know. So we know all these. So almonds are more expensive than peanuts, even though peanuts are better. Almonds are $7 a pound, peanuts are $3 a pound, and our mix is going to be $4 a pound. Peanuts have more protein. And then the income, so if you sell A pounds of almonds at $7 a pound, your income from that part of the mix is 7A, right? 7 times A. Your income from this part of the mix is 3 times P. Your income for the entire mix, you could have done that. You want to make a 20-pound mixture that sells for $4 a pound. So the total you're going to get off that mixture is 80 bucks. Okay, so they're all products. But that wasn't given, right? We had to think a little bit to even get that number. Okay, so the first and the second and the fourth really column give you your equations. We knew that A plus P had to be 20, and now we know that 7A plus 3P has to be 80. So it's weird, but like this, the $4, it factored in, it mattered, but you're actually not going to see that anymore once you actually have your equations. And there they are. 7 times however many almonds plus 3 times however many peanuts is the total value monetarily of the mixture, which is 80 bucks. Okay, so that was the hard part. The rest is just a pretty simple system. So let's bomb through it. Let's use substitution. Let's plug that into the other equation. Let's distribute and combine like terms. It almost looked for a second there like we were going to get a negative number, which hopefully you would think, wait a minute, that don't make no sense, right? But we don't, because it's negative 4p equals negative 6c, so p is 60 over 4. So there you go, 15 pounds of peanuts. So that means, again, this is easy, we're going to have to use, what, 5 pounds of almonds. Should make sense that we're using more peanuts because our mix is only $4 a pound, which is a lot closer to this $3 a pound than it is to the $7 a pound, and also because, once again, peanuts are better. There you go. Truly the king of nuts. They're not even nuts, they're legumes. So 15 pounds of peanuts, 5 pounds of almonds. You can write LB instead of pound because of some weird British stuff that I don't really remember why. Okay. All right, last one, I promise. So once again, you can see that it's a mixture problem. We're mixing two things together. It looks different. It's got percents and stuff in it, but my hope is that once we set it all up and make the table, you realize it's actually not really that different at all. So here we go. A lab tech needs to mix an 8% alcohol solution with a 14% alcohol solution to make 6 liters of a 10% alcohol solution. How much of each should she use? Okay, so you have solution A and solution B. We don't know what all's in it, but we know that we'll just assume it's water and alcohol or something. One of them has 8% alcohol content. The other one is 14% alcohol. We want to mix the two together to get something that's somewhere in the middle, and we want that to be 10% alcohol. And we want 6 liters of it. So that should sound kind of familiar, like, oh, 10% of our 6-liter solution is going to be alcohol. So that's like the total amount of alcohol in our solution. So amount as in liters, that's a measure of volume. So that's going to give us an equation. But again, right off the bat, we're using X amount of this stuff, Y amount of this stuff. We want 6 liters of stuff at the end. So that's our easy first equation. X plus Y has to be 6. Okay, table. I called them solution A and solution B. Not for any reason, just because I didn't know what they were called. Okay, and there's so once again, our first column is an amount. Our second column is like a rate. It's like, okay, we have this much of this stuff, and it either costs this much, or it's worth this much, or it has this much of this other stuff in it. And in this case, it's the third one, so it's how much of it is alcohol. And then then the third column is again a little weird, and it's the total amount of alcohol in like our solution A. So for example, if I had 5 liters of solution A, and I know the solution A is 8% alcohol, then like the total volume of the alcohol in it is whatever 8% of 5 is. So once again, that's a product. All right, so we have A of A, we don't know, B of B, and 6 of the total. So the third row is always like a total. The percent alcohol we know, we were given A is 8%, B is 14%, the mix we want to be 10%. So we know that we're using decimals. You just get rid of the percents. Then you never use percents in math. You always convert them. So it's 0.8, 0.14, 0.1. The total alcohol, okay, if we have A of something and 8% of it is alcohol, then the total alcohol we have in that first chunk, the first, what we're mixing is just 8% of A. And in math, that translates to 0.08 times A. And the amount in solution B is 0.14 times B, and the amount in the mix is 0.1 times 6. So that's an actual number. I didn't compute it yet. It's just 0.6. We will in a second. You need to see where I got it. Okay, so the total amount, volume-wise, of alcohol in our mixture is 10% of 6, or just 0.6. Okay, so that's our first equation. A plus B is 6. Our second equation is going to be 0.08A plus 0.14B equals 0.6. Okay, and I would encourage you to pause the video and just solve this real quick. You should be getting pretty good at it. So substitution again, you'd say A is 6 minus B. There you go. Distribute. Combine like terms. Divide. B is 2. Okay, so that was easy. And then the next part is even easier. If B is 2, A has to be 4 because they add up to 6. And then just because we like to summarize, we're saying 4 liters of solution A and 2 liters of solution B. Okay, so these are weird and specific, but I guarantee I'm going to put one on the test. So absolutely get in the homework and try a couple of these on your own. Okay, thank you.